Hi everyone, welcome back. Today we're going to be talking about functions. A function is a relationship in which each input has exactly one associated output. Let's talk about the first example. It says Tu and Khadija are both first-year college students at Highline. They are both wanting to start a snail mail group where everyone in the group sends letters to every other person in the group. At first, the group starts off small, only containing Tu and Khadija, so there are a total of 2 letters sent. Tu sends one to Khadija, and Khadija sends one to Tu. Reina decides to join the snail mail group, and now there are a total of 6 letters being sent out. Reina sends a letter to Tu and Khadija, Tu sends a letter to Khadija and Reina, etc. Complete the table based on the description above. So let's look at this table. So I'm just going to go ahead and draw the scenario when there are 3 students. So there's Tu, there's Reina, and there is Khadija. Okay, and so Khadija is sending a letter to Tu and also one to Reina. Reina is sending one to Tu. Tu is sending one to Reina. Reina is sending one to Khadija, and Tu is sending one to Khadija. So if I were to count all of those letters being sent, there would be 1, 2, 3, 4, 5, 6 of them. Well, what if I wanted to add a 4th person? Because we want to fill out the next table row, and so I'm going to go ahead and throw in a 4th person. So let's say that person is me. So here's Mr. Kwan. I want to get in on the action. So now, let's see, Khadijah's sending one to Tu, Tu's sending one to Khadija. I'm going to draw these arrows. And then those were originally there, but then Mr. Kwan needs to send one to everyone, and everyone needs to send one to Mr. Kwan. So I'm going to go ahead and add in those arrows. These are a lot of arrows. Okay, let's see if we can't count those. So the ones with the purple circles, there's already 4 of them. And then 5, 6, 7, 8, 9, 10, 11, 12. So if there were 4 people in the snail mail group, there would be a total of 12 letters being sent. Now, I'm not going to draw out that graphic again for 5 people. That's just going to be a lot of arrows that we have to draw. And so I'm going to let you know that when there's 5 people, there are going to be 20 letters sent. Take a moment and pause the video. See if you can figure out how I came up with that number. If you have to draw a picture, go ahead. Or maybe there might be a different way of figuring out that number. Part B says, do you see a pattern? Can you come up with a general rule for figuring out the number of letters being sent for any number of people? Do you think that this represents a function? So let's talk about it in general. Maybe if we were including 100 people, how many letters would be sent? Well, it would take a really long time to draw that image and draw all of the arrows for 100 people. So hopefully we can develop some kind of rule that says how many letters would be sent for any number of people. Well, let's think about it for a minute. If we had 100 people, each of those 100 people would be sending almost 100 letters each, except they wouldn't be sending 100. Every single person within that 100-person group would be sending 99 letters because they wouldn't be sending a letter to themselves. So let's say that there is the first person. They would be sending, not 100. They would be sending 99 letters. The second person, they would also be sending 99 letters. The third person, they would also be sending 99 letters, and so on and so forth. Now, I'm not going to write that out a bunch of times, but essentially I want to add 99 plus 99 plus 99, and I want to do that 100 times. Thankfully, we have a way to do that in mathematics, and this essentially equals 100 times 99 because we're adding 99 100 times. And if we simplify that, 99 times 100 is 9,900 letters. So that's how many letters would be sent if we had 100 people. So in general, the number of letters being sent would be the number of people times the number of people minus 1. And, that's kind of a long task to write out that sentence. And so oftentimes we mathematicians have developed a shorthand by creating an equation. So you can use whatever variables you want, just as long as you define the variables. So I'm going to let capital L be the number of letters, and I'm going to let lowercase n represent the number of people within the group. So the number of letters being sent is going to equal the number of people times the number of people minus 1, where capital L equals number of letters being sent, and lowercase n equals number of people in group. Okay, so the last part of that question asks, do you think that this represents a function? It does, because for any number of people n, there's going to be exactly one specific number of letters being sent out, not multiple. So if you go back to the analogy of the vending machine, if I were to input some number of people, there's only going to be like one snack popping out of the vending machine, not multiple snacks. So based off that description, we would say yes, it does represent a function. Okay. The vertical line test is a way to tell if a graph represents a function. It says that if you are looking at a graph and can draw any vertical line that intersects or crosses two different points on the graph, then it is not a function. Otherwise, the graph does represent a function. So let's look at this second example. It asks us to look at the graphs below and determine whether or not they are a function. If they are a function, state the domain and range of the function. So in part A, we have this red circle. It is centered at the origin, or the point 0, 0, and it has a radius of 3. So the vertical line test says that if I draw a vertical line anywhere on the graph, and if it intersects our graph at more than one place, then it is not a function. So I've just gone ahead and I've drawn a vertical line, and notice that I am hitting 2 points on our circle. That means that this is not a function because it does not pass the vertical line test. So let me draw just another vertical line to represent this. So I've drawn the vertical line x equals -2, and notice that it is hitting the graph at two different locations. If I went back to the vending machine analogy. What that would look like is if I pushed -2 on the vending machine, notice that I'm getting two different outputs or two different snacks from my vending machine. So this indicates to us that this is not a function. So I'm going to go ahead and just write that off to the side. This is not a function. It does not pass the vertical line test.